How does a simple pendulum look? Suppose my length of string is L, then is this distance L cosine theta? And the center of mass gets raised by distance h. And the total length of my string is L. So can I write h as L minus L cosine theta? So far, so good? Okay. Then it asks us to write the Lagrange function, which is t minus v. We know in our polar coordinates, x equals r cosine theta and y equals r sine theta. We do not deal with x's and y's anymore, right? Because we are talking about a pendulum swinging. So we are going to change the coordinates. So what is x dot? R dot cosine theta minus r sine theta theta dot. Okay, then this one will be y dot equals r dot sine theta plus r cosine theta theta dot. So here's why this happens. D over dt of cosine theta is minus sine theta d theta over dt, which can be rewritten as minus sine theta theta dot. Now, what was t? T was 1/2 mx dot squared plus y dot squared, because we're working in 2D, which implies I should square these. So x dot squared should be r dot squared cosine squared theta plus r squared sine squared theta theta dot squared minus 2r dot cosine theta r sine theta theta dot. And then what will y dot squared be? Sine squared theta plus r squared cosine squared theta theta dot squared plus 2r dot sine theta r cosine theta theta dot. I am looking for x dot squared plus y dot squared. Can I add these two equations? Which means this will go away. What is cosine squared plus sine squared? 1. So will this reduce to x dot squared plus y dot squared, r dot squared plus r squared theta dot squared? Because cosine squared plus sine squared is 1. T, which is 1/2 mx dot squared plus y dot squared, which can now be written as m r dot squared plus r squared theta dot squared. Where theta dot means d theta over dt, right? Where r dot means dr over dt. So now the last thing that's left is for us to find the Lagrangian. So what is the Lagrangian now? L is defined as t minus v. When my potential goes from here to here, from this spot to this spot, so there will be potential energy here, which is equals to mgh. What is the potential energy here? 0. So then that means this will be defined as 1/2 mr dot squared plus r squared theta dot squared minus mgl 1 minus cosine theta. So since In a simple pendulum, what is R? And what is R dot? What is dl over dt? Is L a constant? Derivative of it should be 0. What will my Lagrangian reduce down to? Theta dot squared. MGL 1 minus cosine theta.